Hello everybody, I am Muhammad Azhar Iqbal Nawalgund, Assistant Professor, Department of Physics, Government First Grade College, Mundargi. This is the first session on transient currents and the 14th section for the BSc 3rd Sem CBCS students of the colleges which are affiliated to the Karnataka University. Today we are going to discuss the charging of a capacitor through the resistor. Learning objectives. In this transient current unit, you are going to learn the theory of growth and decay of the current in RL circuit, derive the equation for time constant during the growth and decay of current in RL circuit, plot the graph of time against the current for growth and decay of current in RL circuit, which you have already learned in the previous sessions. In this session, you are going to learn the theory of charging and discharging of a capacitor through a resistor. Derive the equation for time constant during the charging and discharging of a capacitor through a resistor. Plot the graph of time against charge for charging and discharging of a capacitor through a resistor. Understand how to measure the high resistance of a resistance by leakage method, and problems on RL circuits and problems on RC circuit as well as leakage method. Session outcome. After studying this session, you are going to understand theory and derivation of time constant equation for growth and decay of current in RL circuit, able to plot the graph of time against the current for growth and decay of current in RL circuit, understand the theory and derivation of time constant equation for charging and discharging of a capacitor through a resistor, able to plot the graph of time against charge for charging and discharging of a capacitor through a resistor, understand how to measure the high resistance of a resistor by leakage method, able to solve the problems on RL circuits and able to solve the problems on RC circuit as well as measurement of high resistance by leakage method. Prerequisites. We already know the meaning of transient current, growth of current in RL circuit, equation of time constant for growth of current in RL circuit, how to draw the graph for growth of current in RL circuit, decay of current in RL circuit, equation for the time constant, decay of current in RL circuit, graph for decay of current in RL circuit, comparative graph for growth and decay of current in RL circuit. Growth of charge or charging of a capacitor through a resistor. A capacitor C and a resistor R connected to a cell of EMF through a two-way key as shown in figure. Here this is the capacitor and the resistor. They are connected to a EMF with the two-way key. Here when this is closed, this path is completely closed. When this key is closed, this portion is closed, this path is, that means the circuit is disconnected with the EMF. When the space of 1 and 3 is closed with the key, a momentary current I flows through R at any instant t. Let Q be the charge on a capacitor of capacitance C. Potential difference across the capacitor is equal to Q divided by C. Potential difference across the resistor is equal to R into I. The EMF equation of the circuit is E is equal to Q divided by C plus R into I. Call this as equation number 1. E is equal to Q divided by C plus R into dq by dt, because I is equal to dq by dt. The capacitor continues getting charged till it attains the maximum charge Q0. At that instant, I is equal to dq by dt, that is equal to 0. The potential difference across the capacitor is E is equal to Q0 divided by C. That is, when Q is equal to Q0, dq by dt is equal to 0 and E is equal to Q0 divided by C. Therefore, Q0 divided by C is equal to Q divided by C plus R into dq by dt. Or this equation can also be written as q naught minus of q is equal to C into R into dq by dt, or dq divided by q naught minus q is equal to 1 divided by CR into dt. Call this as equation number. Integrating minus of log q naught minus q to the base e is equal to t divided by CR plus k, where k is a constant. When t is equal to 0, q is equal to 0. Therefore, minus log q naught to the base e is equal to k. Therefore, the above equation can be written as minus of log q naught minus q to the base e is equal to t divided by CR minus of log q naught to the base e, or log of q naught minus q to the base e is equal to minus t divided by CR plus log of q naught to the base e. Log of q naught minus q to the base e minus of log q naught to the base e is equal to minus of t divided by CR. Or this equation can also be written as log of q naught minus q divided by q naught is equal to minus t divided by CR. Or q naught minus q divided by q naught is equal to e raised to minus t divided by CR. Or this equation can also be written as 1 minus q divided by q naught is equal to e raised to minus t divided by CR. Or this equation can also be written as q is equal to q naught into bracket 1 minus e raised to minus t divided by CR. Call this as equation number 3. The term CR is called time constant of the circuit. At the end of time t is equal to CR. When t is equal to CR, q is equal to q naught into bracket 1 minus e raised to minus 1. That is equal to 0.632 q naught. Thus, the time constant may be defined as the time taken by the capacitor to get charged to 0.632 times its maximum value. The growth of charge is as shown in the below figure. It is the growth of charge of the capacitor, and this is the decay or discharging of the capacitor. The rate of growth of charge is dq divided by dt is equal to minus of q naught divided by CR into e raised to minus t divided by CR, or this is equal to 1 divided by CR into bracket q naught minus q. Thus, it is seen that smaller the product CR, the more rapidly does the charge grows on the capacitor. The rate of growth of the charge is rapid in the beginning, and it becomes less and less as the charge approaches nearer and nearer the steady value. Recap. In this session, we have studied the growth or charge of a charge in RC circuit, equation of time constant for growth or charge in RC circuit, graph for growth or charging of charge in RC circuit. On the basis of this session, there are some multiple choice questions. Question number 1. The RC circuit is one which consists of option A, resistor and capacitor in parallel, option B, resistor and capacitor in series, option C, resistor and inductor in parallel, option D, resistor and inductor in series. The correct option is option B, resistor and capacitor in series. Question number 2. At DC, capacitor acts as option A, open circuit, option B, short circuit, option C, resistor, option D, capacitor. The correct option is option A, open circuit. Question number 3. In an RC circuit, when the switch is closed, the response is dash. Option A, do not vary with time. Option B, decays with time. rise with time. Option D, first increases and then decreases. The correct option is option B, decays with time. Question number 4. The expression for growth of current in RC circuit is option A, Q is equal to Q naught into bracket 1 minus e raised to minus t divided by CR. Option B, Q is equal to Q naught into bracket 1 plus e raised to minus t divided by CR. Option C, Q is equal to Q naught into bracket 1 minus e raised to plus t divided by CR. Option D, Q is equal to Q naught into bracket 1 plus e raised to plus c divided by CR. The correct option is option A, Q is equal to Q naught into bracket 1 minus e raised to minus t divided by CR. Question number 5. A steady state, the charge in the capacitor is option A 0, option B infinity, option C minimum, option D maximum. The correct option is option D maximum. The books which are referred for these sessions are Electricity and Magnetism by Murugesan, Electricity and Magnetism by Vasudev, Fundamentals of Electricity and Magnetism by Vasudev Ghosh, Electricity and Magnetism by Agrawal, Electricity and Magnetism by Brijlal and Subramaniam, Electricity and Magnetism by Sehgal and Chopra, Electricity and Magnetism by K.K. Tiwari. Thank you.